Hi there, my name is Philip Murphy. I'm a catchment scientist with the Local Authority Waters Programme, and I've been asked to give a talk on the implementation of EU and national policy from my perspective. So, the Local Authority Waters Programme, just to explain a small bit about that, it's a catchment assessment team, which means we look at work, we carry out work around the country relating to water quality. There's 36 scientists involved, working all around, and I'm based in the southeast region. And I work, the program itself is a part of the local authorities themselves, so it's a joint campaign, I suppose, carried out by Tipperary and Kilkenny County Councils. So down here in the southeast region, most of the counties I work in are from Tipperary across to Wexford, up to Wicklow and including Carlow and Laois. So we work in targeted areas or priority areas for action around that region. Before I go on, I just want to explain the term catchment because it may not be the same for everyone. It can also be interchangeable with watershed or water basin. And at its most basic, catchment is an area of land around a river or lake or other body of water. So it's the landscape that surrounds the river, stream, tributary, or lake. That's probably the simplest way of thinking about it. So that size of an area that may be under assessment, for example, can vary depending on either what you're choosing to analyze. It could be just a subsection of a river or a lake. So the catchment area may be relative to that, or it can be to the topography scale, say, where the Shannon is our biggest river, one of our biggest rivers in the country, and the catchment area spans almost half the country. But then we look at smaller tributaries to the Shannon or tributaries to the Suir, which would be a much smaller area, kind of a parish-sized area, if you like. So my own background then, just quickly, I'm from a mixed farm enterprise at home with dairy cows, arable crops, and silage contracting. I went to UCD from 2010 2014, and I really enjoyed my course in agri-environmental science, but the PWE probably stood out for me the most, the work experience. I was lucky enough to get the opportunity to go to Trent University in Ontario to work as a student assistant there on an air quality monitoring program in Toronto actually as well. So I really enjoyed that experience. Great to get that at a young age and kind of gain that independence of going abroad. I came back to work on a sheep farm in the Nire because I didn't have that background, so I wanted that insight. And then I finally had work experience in Johnstown Castle at Teagasc, which probably, in fairness, was the one that stuck with me the most because the topic that I worked on there. I suppose it influenced me so much, I ended up applying for a PhD in Johnstown Castle after my undergrad, which I was successful in getting. And I carried out a PhD on evaluating the role of nutrient management on pasture-based farms. I evaluated nutrient balances at multiple scales during that. So during my PhD, I got a short-term bursary to work in New Zealand on a farm nutrient modeling project, which was another fantastic experience. And something that stuck with me and I suppose motivated me to see out the thesis. I was almost 4 years part-time with the PhD and 1.5 years part-time. And why I say that is because this job came up just near the end of my PhD time, and I hadn't seen a role with this title before, and I felt it was very relevant to what I was interested in. So I applied for it and I got the job, which meant I had to put the thesis into part-time mode rather than full-time, which I wouldn't recommend, but that's how it worked out, and I was able to finish that thesis then in 1.5 years part-time. So this job then as a catchment scientist, specialized in agriculture, it was advertised as an agricultural scientist, so I felt I couldn't not go for the role to see what it was like. And I'll explain a little bit about that now. The catchment scientist, I'm going to explain a little bit my perspective and I suppose how it changed a little from where I was in Teagasc to where I am now in this local authorities waters program. How the training, I suppose, changed that, and then just to link us back to the policy side of things, the River Basin Management Plan is a document that was handed to me when I suppose came into this role, And it's through that I got, I suppose, a little bit more familiar with the policy that we were implementing here in Ireland. So my perspective then from the nutrient management side of things, which I came entirely from in the Teagasc, my Teagasc experience, we always followed this model for nutrient transfer, nutrient process. So nutrients I'm referring to, um, it's your chemical fertilizers and your organic manures and the nutrients that are used for crops, and how they move through a system and can end up in our environment, maybe as in our rivers or as emissions such as greenhouse gases and that. But this is the concept, I suppose, that we used all the time. And it explains how, here's the source of our nutrients. It becomes mobilized through various factors, takes multiple pathways, and eventually gets delivered to what's supposed to be, or this is the river, I suppose, or the receptor, where it causes an impact. So that's what I was most familiar with in Teagasc. So the measurable items, I suppose, that was typically nutrient budgeting, soil fertility, fertilizer use, and application timing. So that's what we focused on, getting those things right, and we assumed to an extent that the pathways and delivery would lead to a minimal impact in our rivers if we had those things right. So then I came to this job, and it was the other way around. It was almost flipped upside down. It's the measurables in this case are the actual nutrient levels in the river. So that's what's been lost, say, to our rivers from this process. So excess nutrients, or in some cases maybe not excess, but on a pathway that's a vulnerable pathway or a critical source area, the nutrients could be lost without being in excess. So we looked at ecological status, invertebrates, and physiochemical parameters here, which are your temperature and your dissolved oxygen. So these were our measurables here, and that's what we worked on. So it meant that we had to think about this stuff again up here, make sure that that's right. If that's right, we can ensure there's no impact going on down here. So through the training that I was provided here, it was shortened up to a small extent to just source, pathway, and receptor. The receptor here being the river, and it relates to the same thing as the impact relates here. So that's I suppose how my perspective changed, and why I think that's important is to say that whatever role you're in, it's good to know exactly what perspective you're looking at things from, because it helps to see what perspective other people are seeing things from, and you might be trying to solve the same problem. So it's important to know that. I just felt it was important to share that. So I started in summer 2018, and I came in the door and was handed this book in my new job as a catchment scientist. This is the River Basin Management Plan for Ireland, and as you can see, it's a nice looking document, and it's full of information that's important for the policy relating to Ireland. So I'll get into that now. Okay then. The River Basin Management Plan for Ireland, I'm just going to pick out a few of the main points first to start us off. So this is as I said, the document that gets you thinking about the policy side of things, and why, for example, my role in this job exists, and why other organizations are doing what they can. So as you can guess, the River Basin Management Plan will be about water quality. So the first few points that come out are that stick out are this 190 areas for action, meaning that something already has been prioritized within Ireland for resources, and in this case catchment assessment. So that's the first thing that jumps out. The next thing is the results of what they found, or what's been reported in this book on the receptor. So that's our rivers and lakes and all that. So that's at the far side of that nutrient transfer process that I was talking about. So these are the figures we're shown: 57% of rivers, 46% of lakes, 79% of coastal waters, and 91% of groundwater are said to be compliant with EU standards from 2015. So when you want to find out what compliant is, you end up chasing a string right back to what's called the EU Water Framework Directive. And that's what I'll be explaining next. So let's find out what compliant with EU standards means. So when it relates directly back to the EU Water Framework Directive, we looked up with a definition for this, and that is that the WFD is a response to the increasing threat of pollution and increasing demand from the public for cleaner rivers, lakes and beaches. And of course, that's what everybody wants. We don't want to be swimming in polluted waters or paying more to get our water cleaned so that we can drink it. So this was obviously a big issue on a continental scale, and all member states found that it was important to have a directive that would protect our water quality across our rivers and lakes. So the four main objectives of the WFD then are to protect and improve and prevent deterioration of all water types. To achieve good status for all waters, this is the standard that the EU want us to comply with, and that's what those figures in the previous slide relate to. The third objective is to involve the public, and the fourth objective is to use a river basin catchment approach. So these objectives are applicable to all member states of the EU. So they're a little bit broad and kind of catch-all because each member state is expected to implement them differently. And this slight broadness in the objectives gives us a chance to adapt them to suit the member states, such as Ireland. So within it, I suppose it's important to understand that a lot of the EU policy, that continental scale policy, I suppose, is transposed into national policy. And these are examples that I've listed here, so I won't go into them, but this is just to give you an idea that there's a lot of legislation that's transposed from EU policy to Irish, I suppose. So that's those there. The water framework itself, then, it really does interact with all these other legislative and regulation aspects. I'll be focusing almost entirely on the nitrates, but there's pesticide use, there's floods, drinking water, all those relate to the Water Framework Directive. So that's, I suppose, an important lesson to learn, that these things all have a string that attach back to the Water Framework Directive. But for the moment, we're going to focus on the objectives of the WFD and how we applied them in Ireland. So the River Basin Management Plan, this was the health check. So these are the results I spoke about earlier. This was the first thing that they showed almost in that book. And so now we understand that 50% and what it means. So the EU compliance. It means meeting the target of good status, and that's what the compliance is. It's the same for the rest of all these water bodies. We have the lakes, 46% are compliant, 79% are compliant, 91% of groundwaters are compliant. So that means they're within their good status objective. Obviously then that means there's 43%, just in the case of rivers, that are not at good status, and they require our time and resources to bring them up to that good status in terms of water quality. So of that 43% of water bodies that are impacted, we're just going to look at what the pollutant sources are for those impacted rivers. And in this case, we're looking at all waters combined. So that means lakes and rivers, groundwaters and coastal. So of all the water bodies, the most likely source of pollution is agriculture. So that's 53% of the water bodies are impacted by agriculture. It's mainly down to the amount of land use that's given to agriculture in Ireland. So we're an agricultural nation, but it is the most likely pressure on a water body across the whole country. So we're going to focus on that. Followed by wastewater treatment plants, and then hydromorphology, which relates to drainage or manipulating a river to change its direction or that kind of stuff. So those are a separate category. Now some of those can include agriculture, but we'll just focus on this pressure for now. So of the water body types impacted by agriculture, there's almost just over 600 rivers impacted by agriculture, followed by just under 100 lakes, and then less and less are impacted by coastal, transitional and groundwater, but they are not insignificant. They all need to be addressed, especially our groundwater, because that's something that should absolutely be protected. Groundwater is mostly used for drinking water, so we need to protect that. So now that's looking at those results, the breakdown, we've I suppose achieved 2 of the WFD objectives so far, just by identifying the pressures. So we want to protect and improve all water body types, and that's all of these down here. We're not just focusing on rivers, we're not just focusing on lakes, We're focusing, we're taking them all into account so that they can be addressed. And then we're trying to achieve good status for all rivers. So that's what the percentages meant, as I showed you. We're trying to get all these into our good status objective. So the next WFD objective was to involve the public, and then the final objective was to use a catchment approach. So the other side of the same house, as we say, is the community water officers. And down the corridor for them is the catchment scientists. So that's us. I started in 2018, 36 scientists, as I said. But prior to that, there was community water officers who started in 2016. And these people initially, they started this, I suppose, program first, and they were driving the public engagement side of things. So they were always involved in getting the public, community meetings, your community groups, like your tidy towns, but there would have been groups dedicated to improving local water quality. These people specialized in that, and they were at it for 2 years before we came along. And so it's only in the last number of years have they had a full house, as we say. We've the community officers driving that in public involvement, specialized people that are capable and really enjoy this side of the house. And then we've the catchment scientists who just came on board in the last couple of years. So together we're in a one house, and probably for the first time we're trying to implement those WFD objectives while all working on the same side. So now of the WFD objectives, we've met them all to this in this example. So we're trying to protect and improve all water bodies, achieve good status, and then involve the public by the community water officers, and use the river basin management approach. So although that's been carried out at different scales, the catchment scientists now will carry it out as probably one of the smallest scales, kind of a sub-river, subsection of a river scale, which allows for a nice bit more accuracy and targeting in catchment assessment. As part of that river basin management plan as well, an organisation was set up called the Agricultural Sustainability Support and Advisory Programme. As I've shown you, agriculture is the biggest pressure on our rivers, so it was deemed necessary to have an advisory service dedicated to addressing that. So here is a picture of a mix of both of us on the catchment science team and the advisory team for agriculture. So that was a very important step, really, because they have a huge role in implementing measures and getting down onto that farmer level where the agricultural issues are I suppose, found. And the catchment science approach allows the advisors to be targeted in their advice as well. So it's a very necessary and appropriate collaboration that's happening here. So the ASAP program has been driven or organised by Teagasc, which is be separate to us here in the local authority waters program, but we work very closely together. In fact, we work so closely together we have a step-by-step approach on how we carry out the work, just to keep us all in line. Okay then, so policy implemented. So I'm just going to talk a little bit about what I do, I suppose, day to day or in a typical year in my role as a catchment scientist. So as a catchment scientist then, just going to focus on what we come out with, I suppose, in terms of outputs typically. So we work in these targeted areas for action, as I mentioned. I'm a part of a team of 6 scientists, including 1 catchment manager. Throughout the year, we produce about 3 reports per area for action. Those reports are the desk study, fieldwork report, and a referrals report. And referrals is our recommendations to an agency or a pressure source, say, could be a farmer, and what measures are needed to improve water quality in an area. So that's what the referral report is talking about. And then we attend public meetings, and this is again as part of that WFD objective. We have to get involved in the public events, which are extremely important because their feedback can actually influence our field work. So we have our community hall meetings and we have our farmer meetings and discussion groups, which I'll show you some of as we go through it. Just to focus quickly on the desk study, this is probably one of the most important steps. We don't just go straight out and survey a river almost randomly and find out if it's good or bad and then make recommendations. That would be fairly inefficient and not very targeted. So we gather a lot of information first in a desk study and generate a report on that. We start by focusing on what the nutrient levels are. Is there excess levels of nutrients in our river? Typically dealing with ammonia and phosphate and nitrate. And we have our thresholds for these that we need to make sure that it's not being breached on a regular basis or it's trending upwards and increasing. Excess nutrients can lead to eutrophication, which can impact the invertebrates or the bugs that live in the river, which actually indicate the water quality. So we find out what the nutrient trends are. We see what the ecological status is, how it's changed over time. The scale we have here, high, good, moderate, poor, and bad. Again, the objective is good. Obviously, we prefer high as well, but we're aiming for good. So we need to find out what's happened, I suppose, historically. Has it been always good, or has it been moderate or poor, or has it been high and dropped down? So this is the stuff we compile, is the information. And then there's some initial assessments carried out by other agencies, like the county councils and other agencies who provided input during some of the public engagement, and that they will indicate what the pressures are in a river that we're studying. So it could be agriculture, it could be an urban wastewater treatment plant, or it could be unknown. So we gather that and make, I suppose, a conclusion on what the most likely pressure is. The information then is also gathered from other agencies like IFI, Inland Fisheries Ireland, Coillte, Forest Service and Irish Water, and anywhere where we think we can get information that would be relevant or may help us essentially in our fieldwork. So that desk study is a stepping stone to being targeted in our fieldwork. Okay then. So GIS, the Geographical Information System. So we're probably familiar with ArcGIS and it's a very important system here to us, and it's a good skill to have when carrying out our fieldwork and for jobs in general. Just taking an example of a river here, a subsection of a river down in Waterford in Tallow. So going by the colour here, it's at a moderate status, so it's one level below good. And we need to find out why it's at that stage, and we need to get that status and get it up to good status. So this is one of our GIS layers. This is just a landscape one, OSI map. Shows us the contour lines, shows us well, in this case I have the flow direction on, and town details and that kind of stuff help us, I suppose, to target where we want to carry out our assessments. We'll only ever carry out assessments in small individual points along the river, but it helps us to target where this pollutant source could be coming in that's causing that moderate status. This is a land use map, shows us what the likely pressures are in the area. So we've arable land here, forestry running down through the middle, and all the blue then is actually pasture. So that'd be just agricultural pasture, grassland, which would be typical. And then urban area, which can also be a source of pollutant if there's misconnections and that type of thing. So another layer we look at is the soil type, which is actually extremely important in terms of analyzing the pathway for nutrients to enter a river. It could be downward through well-drained soils, which is actually the case in this catchment, in this river. The well-drained soils allow nitrate to permeate down through it, and they come up either just under the surface and eventually up into our main channel for the river, and it can increase the nitrate levels where the nitrate levels are too high. So that's a soil type layer that we use. We have some extra tools then that we can use to try and, I suppose, again, get more targeted. In this case, I'm looking at a phosphate loss risk map, also known as a PIP map. The deep blue here means the biggest risk of phosphate loss to a river is going to be here. But as we can see, the majority of this catchment is in a light yellow or a green, which means there's no risk of loss at all, really. So that's the case there. We also have a nitrate risk loss map, and we can see there's a lot more of those darker colors, which mean nitrate loss is greater, which obviously lines up well with our soils map, which says there's a lot of well-drained soils on pasture, a large area of pasture. So that's just one of the tools, I suppose, that we use to get more targeted and get a very, I suppose, accurate as accurate a picture we can get before we go down onto the river. And from those steps, then we come up with the source pathway receptor, which is something that I explained in the nutrient transfer process. And it's very important when we're making our assessments and our conclusions to identify what way nutrients may be entering the river. In some cases where it's poorly drained or a wet soil, the nutrients may run straight off, provided the source is there and provided the pathway exists to allow nutrients to run straight off and into our river. A buffer here might break the pathway and stop those nutrients going in, or careful management of nutrient sources here may minimize the amount of nutrients coming in. In this case, the R here, that's the receptor, so that's our stream. So that's one pathway over land. Our second pathway, now we're not limiting it to two, but just as an example, nutrients may go downward through the soil and come up via groundwater into our receptor as well. So in that case, a buffer may be no good, as the soil is allowing nutrients to move downwards and up. So that's just another very important step in our analysis, because when we want to recommend measures, we want to make sure we're recommending the correct measures to prevent nutrients entering the river. So our other role is the public engagement. So this is a community meeting, actually again in Waterford, in Rathgarmach, and we just give a talk about what kind of work we're doing in the area, and the public comes out and would, either ask plenty of questions about what's happening in the area, what's their local water quality, or they may have feedback for us that could be useful, something that we didn't pick up in a desk study, or something that they're wondering about locally, is it a problem or not? And we'll try and answer those questions, and we'll provide feedback when we can as well. This is a farmer discussion group in the Dynon in Kilkenny, the River Dynon. These are ASAP advisors. As I said, we work very closely, so it's like a two-part meeting where the catchment scientists will describe the problems in the river in the area, and then the advisors explain some general measures and practices and actions that would help to prevent pollution loss from agriculture specifically to the local river. So again, this is another meeting we had up in Laois, where we engaged with farmers just to inform them of our process. Fieldwork. So once we're happy that we know what our source of our pollutant is, the pathway, and we know what the status of our river is, the receptor, we'll go out and start picking a number of different sites along a river. We try and find suitable habitats of where we want to sample to find out what the water quality is like there. We spend a nice bit of time targeting specific sites so that we can be, I suppose, accurate in our assessments and in our conclusions. And while we're out there, we come across, I suppose, issues like this. We need to decide whether that's actually a significant issue for the river or not. And our assessments out there will help to determine that. So that's the kind of questions we need to ask when we're out there. Then in terms of what the assessment itself looks like when we're out on the ground in our rivers, we carry out what's called a kick sample to gather evidence of impact, and that's the most important thing. If there's no impact, we're not going to make any conclusions or recommendations, so we need to gather evidence of that. We use a number of signposts for gathering that evidence of impact. The first is macroinvertebrates. We look at the other environmental factors like plant growth, macroalgae, and the plant type, and then chemistry levels. We'll take samples of the various factors that can affect the health of a river. But the most important one really is our macroinvertebrates. So we'll go out to a site like this. We'll take a kick sample using this net to gather up these invertebrates. Just by kicking the bottom of the river here and keeping this net downstream, these invertebrates will flow in. So this is our biological sample, I suppose, is an easy way of thinking of it. And that will give us an indication of what status, not even the status, what health of the river, of that habitat is like, depending on the types of invertebrates that we find and the amount of them as well. So we're looking for Ephemeropta or mayflies and Plecoptera or stoneflies mostly there. The more of those we find typically means a healthier river. And they're also an indicator of a kind of a long-term habitat quality for them. So up to 6 months or more, depending on what's been going on in the river, versus, for example, a chemistry sample might be only representative of a single day, what was going on in that day, whereas these guys are a long-term indicator. So Depending on the types that we find, we carry out a survey, we fill in a sheet, spend a lot of time trying to distinguish between these guys, make sure we have the right guys, and we come up with a conclusion whether the site is impacted or not, whether that evidence is there. We couple that information with our macroalgae information, our chemistry results, and we determine what is likely the cause of the impact, and then we refer to our desk study to see what the pathways are and all that, and we bring it all together to come up with our assessment on a per site basis. And we're trying to be very targeted with this work so that we can be accurate and we can stand over our conclusions and our referrals and recommendations. And that's an example of the macroalgae and plant life that we'll keep an eye out for. Now then, to give a few case studies and scenarios to try and give you the idea of what the experience is like for the catchment scientist. It's not clear cut, a lot of the work, and some of it is and can be. But I'll explain 3 different scenarios that are all examples of the direction that the work can go in. So while we're out there, the procedure, after we've gathered our evidence of impact, we have to make sure a nice few things come together before we get to that referral stage, and send our recommendation to an agency. So one of the first rules we have is that pressure does not mean impact. So if we see a wastewater treatment plant or a forest or a farmyard and it's near a river, we can't say that that farmyard is the problem unless we see an impact that's directly related to it, or unless we see an impact nearby. We have to really untangle the multiple pressures that could be around, to make sure that we're making the recommendations to the right pressure. The other thing we do is we focus on the significant issue. So from our desk study, maybe it's a nutrient problem, nitrate. If we find a small phosphate problem, we're going to focus on the nitrate one because that's the one that's affecting the water status, the water quality status. So we need to focus on it. Not that we'll ignore the phosphorus issue. If it is significant, we won't. But we do focus on our issue for the quality of the river. That's our goal. And the evidence of impact. So that's our assessment, as I showed you, with the invertebrates and plant life and that. And then, of course, the sort pathway receptor must all line up. All this stuff must come together before we generate a referral to the relevant agency. So looking at a river in County Waterford again, the Clodia priority area for action. So our desk study, the first step that we carried out, found that it was at moderate status. The initial pressures were identified as forestry and agriculture, so these were the sources of pollutants or the sources of pressure. There was no nutrient issue identified in the initial assessment, and then finally we worked out what the pathway would be if in this case there's no nutrient issue, but what the pathway would be in terms of where would the water flow in the catchment from the source to the receptor. So this is a graph that we use from the EPA data. This is the long-term results of the status of that Clodia River, that section. So it's remained good for a number of years. It was high for a while, dropped down to moderate, good, and then in 2014 it was moderate again, which is where this initial assessment was based on, was that moderate status. So I know it's gone back to good since, but we need to find out why it dropped that time, and we need to make sure that that's prevented. So there's an example of our nutrient, I suppose, analysis on the EPA data again. There's our threshold. As long as it doesn't breach that point significantly or over a long term, we don't really consider it as a significant issue. So in this case, it's never breached that threshold. And then we plan our fieldwork. So all these white labels are all the sites that we visit in this subsection of the river. That's the boundary of the catchment that we're interested in. So it's everything inside that space that we want to consider when we're making our conclusions. So as I showed you, the multiple sites were selected for assessment. Initially, we found there was no impact near the monitoring stations, which are just the bridges where most of the data is collected from. There's no impact found there. So moving upstream, we did find impacts that would likely lead to problems at the monitoring station. So we gathered that evidence of impact. We carried out our kick samples and our environmental tests, on dissolved oxygen and chemistry samples and that. So this is an example of why we focus on our significant issue. So this was a sediment problem, but it was actually only something that happened on the day. It was a runoff from a road drain, and the recent maintenance to the ditch had let this sediment run off, but it wasn't a significant issue for the river. So we focused on that actual impacts that we did find, which was on the invertebrates, and we could see some macroalgae growth in that. So once we were happy that we knew where the impacted sites were, and we were able to come to conclusions on some of those other pressures, like the forestry pressure that was identified at the start. So that was ruled out. There was no impact relating to forestry found, nothing significant. So at the sites that were impacted, our invertebrate results said that those invertebrates were not in a good condition, and this was backed up by the physiochemical parameters and some of the plant algae in that as well. So we made our conclusions and we made our referrals to the relevant agency. In this case, it was an agricultural related problem, so we generated a feedback loop for us to ASAP. We told them where the sites were, and they tell us, without giving away locations, they tell us what the likely source is, and then we have to try and agree whether the impact that we found relates to the source that they found, again for accuracy and for relevance, so that our recommendations will be correct. This is an example of that feedback loop. So there's our evidence of impact in the river, the low DO, low dissolved oxygen, macroalgae growth, all these things. We make that referral, in this case, as I said, to ASAP, the Agricultural Advisory Agency. We're informed of what it could be, so farmyards, cattle access, this kind of stuff, and they'll tell us not the location, but they'll tell us how significant it is or not, and then together we determine whether those measures will help fix water quality or not. Whether enough could be done by fixing those problems. In some cases we may need to go back out in fieldwork and find other areas because something may not be a significant problem. A little bit too much text here maybe, but the advisory system heads out then. They carry out their meetings with their farmers in the area. That's what it looks like. We have our discussion groups by the stream. Sometimes I'll be invited along to demonstrate the kick sample, demonstrate our assessment, and talk to the farmers in the area about what's going on in terms of catchment assessment and local water quality. And they're often very engaged and very interested in the work. And once they see what can be done and how much the invertebrates and all that can tell you about the health of a river, they're often quite interested in trying to carry out measures or practices that will help prevent any pollution entering the river. So it's a very good process, and again, it's a way of engaging the public. Some of the measures then that they might implement or make sure to implement is the no spread zone, that buffer zone for spreading chemical fertilizer or organic manure, staying away from your river margins so that you're not losing nutrients directly to a river or through overland flow. So the ASAP advisor there may spend the time drafting or drawing maps to show them where they need to spread to prevent that type of loss. So focusing again on the Clodia and its policy relevance. So a little bit much text going on here, but just to focus on these 2 points. So this table is a summary from the Good Agricultural Practices for Protection of Water Quality. That document is directly related to the Nitrates Directive, which is directly related to the Water Framework Directive. So these rules are legally binding for farmers in all across the country, and it depends on their enterprise and their stocking rate and that kind of stuff. About there might be small differences in rules, but these are the basic legal rules that farmers need to comply with. And in our case for this Clodia, there was a farmyard issue that led to a loss of manure and I suppose watery runoff that led directly to the river, and that's where I found impacts. Now, I don't know where the yard was or how far away it was, but I only found the impact in the river, and the advisor found, I suppose, where the farmyard was. So in that case, the farmer was actually legally required to put in those measures because those are the minimum standards. the measures here relate to the collection and holding of the gap regs here. So they're supposed to meet that minimum requirement. I'm pretty sure it was a once-off thing. It was something that happened during that summer, and it's something that the farmer was able to address almost immediately once it was identified. So that this whole scenario then is relates to measures for the farmer and at the farm level that were legally required through the Nitrates Directive and ultimately through the Water Framework Directive. So for our second case study, we're still staying in Waterford in the Tay PAA. So this is a subsection of the River Tay. Just going straight to the policy relevance part here, relates to cattle access and how the measures are implemented in this case. This is the cattle access here. This is looking at the monitoring point here. The bridge actually is an EPA monitoring point where they collect most of their information. And this is looking upstream here, and that's the same cattle access. So the difference in this case relates to setback distances. Again, we're looking at the good agricultural practices, the GAP regs, which relates to the Nitrates Directive, which ultimately goes back to the WFD. So in this case, the cattle access, it looks bad, and it's quite close to that monitoring point, but there's no rules being broken here. There's no legal requirement to have that cattle access, closed off. It's allowed, provided they're under a specific stocking rate, which is explained here. So there's no legal requirement to close that cattle access. However, the case was there was an impact found just downstream of it. It was a small impact, but the difference in this case was this river, this subsection of river here is actually at high status or high status. And obviously that's the highest status that can be achieved. Pristine waters, I suppose, is another way of putting it. And because of that, it's much more sensitive to, and the invertebrates in this case are much more insensitive to impacts, smaller impacts. And so something like a cattle access might be okay, and say a larger river where the impact might be diluted to an extent. In this case, it's not enough. It was enough to deteriorate it from its high status because the invertebrates are being impacted. So in that case, the measures are actually voluntary because there's no rules at the moment to protect, no legal rules to protect high status, so they have to be voluntary. We need to protect these rivers. There's less than 25 rivers left in the country that are in pristine status. In this case, the ASAP advisor had to ask the farmer to put these measures in voluntarily based on our assessment of the impact and based on our I suppose goals of protecting a high status river, not just achieving a good status, and that's the difference there in that scenario. And then this is our final case study, the Glenaboy PA, also in Waterford, and it's a subsection of the Glenaboy River. So jumping straight to the policy relevance again, in this case it's diffuse pollution, and the measures implemented may require funding. So I'm going to explain that now. The desk study of the initial information that was available when we looked at our nutrient levels, we saw that nitrate was a significant issue. And the way we determined this is this is our threshold for nitrate levels in the river system. And on the monitoring point data that was available, the nitrate levels showed that there was a significant increase and an increasing trend in nitrate levels over the last number of years. And it was consistently above this threshold. It was consistently above this threshold here. So nitrate was, from the desk study stage, we're saying it's most likely our issue that we need to deal with. But how it got there, we don't know yet, really, until we get down to the ground and ground truth this kind of stuff. So we got there, we carried out our assessments. The invertebrates did, there was impacts, there was absence of some of those healthier invertebrate species. And our chemistry results showed that there was increased nitrate levels around that were of concern above those threshold levels. But it was very hard to target it. It was very hard to target it. Was it down to one tributary or was it any farmyard or anything like that? But there was no obvious, pathway or source pathway from being underground. So when we looked to this, we were assuming that the catchment is operating within the legal limits for application limits. Our fertilizer, our stocking rate, we're assuming all that is correct. The advisors were working in the area to generate just target advice on nitrate levels anyway, once they were aware that nitrate was the issue. But and going back to our desk study, when we looked at these nitrate loss maps, we saw that there's some areas that were extremely risk of high nitrate. So as we showed earlier, this area is mostly pasture, mostly grassland pasture. And so we're expecting that there'll be a lot of nitrate nitrate source pressure from the pastoral area, predominantly dairy farms around here with some arable, that would be adding to that high pressure, a high nitrate load. And then if you combine that with these risk areas, based on this map, it's likely that those areas, and across the whole catchment really, there's going to be a lot of nitrate loss risk. And then at the river level, as I showed, we did find that there was impact at the river level. So the main reason for that risk is just the characteristics of the landscape there. It's an extremely well-drained area. It's sloping too. There's areas that have fairly thin soil, so there's less attenuation, say, or less chance of attenuation. So we're looking at a high risk area for nitrate on top of a high nitrate load catchment. And as a result, we had that impact in the site, in multiple sites throughout the river. So in this case, the scenario is different. We don't have, assuming everybody's operating legally in the catchment, they're doing their best the farmers doing their best to have their income and operate efficiently. But due to the characteristics of the landscape, there's no easy way to address this issue. So it does potentially require either specialized funding or specialized rules for a catchment to prevent nitrate loss and reduce that impact on the river. So that's really the last scenario I'm going to go through. The three main ones again were the legal requirements that are expected to protect water quality, the voluntary requirements that are expected to try and keep a high status site, and then in some cases we just don't have the solution yet really, and that rules will need to be made to protect our rivers in specific areas, and that may require funding or those maybe new regulations. So that's our three scenarios then. And then finally, just to show some conclusions through the outcomes from the process of our job and the organization. I've brought you through the context of the policy, what the action looks like on the ground, and what it requires to be confident in our referrals and recommendations. Looking at the ASAP program first, the advisory program, there was a findings report published there representing what was found between 2008 and 2019. They found that there's 6 issues per farm that were assessed, and that the main problems were relating to phosphorus loss via overland flow as a pathway. So that's really a soil type issue there, really, soil type and nutrient application. Buffer zones, so the use of them and I suppose adhering to them, which can be both legally and voluntarily required, and then drinking points and stream fencing. So those are the main issues found across those farms that were surveyed so far, at least in that year. What was also identified was that the implementation of measures is the main limiting factor. So there's a lot of solutions available out there and recommendations, but the implementation of them is really down to the farmer's capacity to do so, be it funding wise, advisory wise, whatever's available. Actually putting those measures on the ground is the real barrier. Identifying solutions can be done, but whether it's relevant or applicable, that's the real challenge of getting measures implemented so that water quality can be protected. So that was another one of those that comes from the process. Finally, this is in relation to the Department of Food and Agriculture and eligibility change, where farmers can, they would have been originally penalised for giving area over to riparian margin, for example. because it's not deemed agricultural land, but that's been changed now to let farmers do that. So that was a legal barrier to implementation that was changed and has allowed farmers to do that. So that's a great outcome from this process, and we hope to see more examples of that. So just looking forward, I suppose, in some of the more recent information, our water quality report, the latest one from 2019, says that nutrient levels are still too high in our waterways, mostly due to nitrate and phosphate increasing in almost a quarter of our rivers, and increasing nitrate in our groundwater, which is it's just not good enough. Really, it's just not trending the right way at the moment, and that needs to be turned around. So as I explained, the context for all our policy and implementation was based on the River Basin Management Plan from 2018 to 2021. So that's the end of this year, and we have a new River Basin Management Plan that's expected to be published now in June, with new targets, new procedures, and new goals for us to really implement this policy on the ground and get our rivers back up to good status as many places and locations as we possibly can. So we can anticipate that coming out then in about June this year. Some of the take-home messages then that I think might be relevant is just to be aware of your own perspective. So what I mean by this is that when you are communicating with other agencies or people, just know your own perspective and know what perspective they're coming from. It does help for communication and understanding problems and even coming to solutions, more importantly. The policy that I spoke about, it's not something to try and stop the agricultural industry or to stop people doing what they want to do. The reason we need environmental policy like that is because we need a minimum standard for social and economic reasons. We need the health of our rivers for drinking and for swimming. We need the policy there. We need to protect. We need to implement it so that we can protect our rivers and that. So policy implemented, as I've shown you, it looks like a lot of things on the ground. It's multiple agencies, it's agencies working together, it's different actions, it's all of that. So, it's being implemented and you can see that all around you. Our water quality issue is significant and we really need to turn it around. It's for the reputation of the country, it's for our agricultural industry. We need to take it seriously and make those actions on the ground happen. Don't let implementation on the ground be the barrier. Let's find out what we can do to get it done, get our water quality fixed. And look, at this stage, it does need to be done locally. It's not a national issue. It's really what could be done at a farm level, an individual farm level, and then that accumulates then to a national solution then. Not all our solutions out there, as I showed you the scenarios that were there. We don't have all the answers, and it takes a lot of work. It takes scientists, this workshops, advisors. It takes the general public. It takes it all coming together to get to the solutions that we need to fix our local water quality issues and that. Finally, as students, as you are aiming to get out there into the world, you got to practice that skill building so you can get into these jobs. Find out what's involved in communicating, find out the agencies around you. What I'd recommend is to try and get into technical or scientific writing, or just find out what level of writing you're at and see if you can build on it in a small way throughout your college course. This stuff does stand to you. It's technical writing sounds tough, but it's a matter of practicing it like any skill, and it does help with your communication across any other job. It's a transferable skill that's really needed. GIS systems may be relevant. It's all there for us to practice and make the most of. So look, in terms of other opportunities, it is likely that there will be similar organizations like mine, but they'll be our subsections that relate to greenhouse gases or biodiversity and other environmental aspects that should be coming in the future. We all need people who can communicate to either the farming community, to other people, to non-farmers. We all need that skill. And as I said, writing is really a transferable skill that can really work in all jobs and all aspects. There's some of the resources then. Local water quality. If you want to find out what the status of your river is, you can go to this website or this tutorial on YouTube. For the GAP regulations, so that's the nitrates directive and the legal requirements for farmers, there's actually a summary version of that available on this website. Our own side of the house, the catchment assessment team and the community water officers, you can find that on this web page. And then the ASAP program, you can find that on that page. And obviously, the ASAP advisory program will be quite relevant to students now. So it's worth keeping an eye on opportunities that may come up there. So that's it for me. So thank you very much for your time. If you want to get in touch, please use this email address, and I'd be happy to engage. You're all members of the public too, so we'll see what we can do in terms of finding out what information that you'd like. So thank you very much for your time, and all the best.